The probability in statistics is the measure of the possibility or likelihood of an event or an outcome to happen. For example, the probabilities of different blood pressure readings are: blood pressure 70 to 100, which is considered as low blood pressure, is 35%, 100 to 120 is 40%, 120 to 180 is 24%, and more than 180 is just 1%. So what exactly is p-value? P-value is the probability value at which the null hypothesis is rejected. P-value can take any value between 0 and 1. Values close to 0 shows that the observed difference is unlikely to be due to chance, or it could have not happened at random. For example, p-value 0.001 means 1 out of 1000, 1 out of 100, 2 out of 100, 3 out of 100, 5 out of 100, 80 out of 100, and so on. The default cutoff commonly used is 0.05, so any value lower than or equal to 0.05 is considered to be statistically significant. P-value 0.05 means that there is a 5% chance that your outcome could be random, and p-value of 0.8 means that there is a 80% probability of being completely random. So the smaller the p-value, the more likely it could not be due to chance. Graphically, the p-value is the area under the tail. Critical region is important because if it falls within this region, then we would fail to reject the null hypothesis. However, if it crosses the critical values, which is the red zone or red area, then we would reject the null hypothesis. P-value of less than or equal to 0.05, which is 5%, is considered as a threshold to differentiate significant from a non-significant result. A researcher has a choice to choose one-tailed p-value or two-tailed p-value. For this, you need to see your research question. For example, if your null hypothesis is that a drug maintains mean blood pressure equal to 120 millimeters of mercury, two-tailed hypothesis will be a drug cannot maintain the mean blood pressure of 120 millimeters of mercury, and it will evaluate both directions, that is, it could either increase or decrease the mean blood pressure. One-tailed hypothesis, however, can only check one direction. You could either evaluate if a drug just increases the blood pressure, or you could evaluate that the drug decreases the blood pressure, but not both directions. Statistically, there will be some differences between one-tailed and two-tailed tests. One-tailed test will have just one critical region, as a two-tailed test will have two critical regions. When performing a two-tailed test, we need to consider alpha by 2 rather than alpha. The critical value for the right-sided one-tailed test with a 5% significance level Z1 minus alpha is 1.645. For the two-tailed test, Z1 minus alpha divided by 2 and value will be 1.96, positive and negative on both sides. The values are obtained from the tables of the inverse of the cumulative distribution function of the normal distribution.